Hypovolemia. It says autoregulatory mechanisms used in hypovolemia include increased precapillary sphincter tone, reduced urine output, reduced baroreceptor activity, stimulation of juxtaglomerular apparatus, and increased angiotensin 2. If examiner asks at the exam from you, what is hypovolemia? What are you going to say? Thanks God, there is no standard definition for hypovolemia. If you have lesser amount of fluid in your vascular system, you can call I am having hypovolemia. That is the definition for hypovolemia. Lesser amount of fluid in vascular system. My vascular system right now contains approximately 5 liters of blood. 5 liters of blood. Due to some reason, maybe dehydration or maybe bleeding, if it is reduced into 4 liters per 4 liters, you can call Dr. Dinusha having hypovolemia. Then what happened in my body? When my vascular volume reduced, when I become hypovolemic, compensatory mechanisms start to activate. Can you maintain previous blood pressure now? No, you can't maintain blood pressure. Blood pressure start to drop. Can you maintain previous organ perfusion now? No, blood pressure start to drop. Organ perfusion also affect. Also going to reduce. Then your brain think, now I should preserve only vital organ. Are there any non-vital organ in your body? Yes. GIT tract, skin, musculoskeletal system. Yes, your gonads. They think those are non-vital. They think vital organ are the brain, heart and kidney. Somehow they try to preserve blood supply to that organ and cut off blood supply to the other organ. Then they can maintain vital organ perfusion until you recover from this hypovolemic condition. Then what they did? They reduces the blood supply to the non-vital organ. How? They increase the precapillary sphincter tone. This is arterial end of the capillary. This is venular end of the capillary. This is your capillary. There is precapillary sphincter. What happened now? You having hypovolemia. This is non-vital organ, maybe skin, maybe musculoskeletal system, maybe GIT, gastrointestinal tract. So sphincter going to contract, therefore blood coming will be reduced. So those vascular bed, non-vital organ vascular bed start to suffering. Why? Increase precapillary sphincter tone. Other organ maintain. No precapillary sphincter activity is there. But if you develop severe hypovolemia, sometimes those capillary bed also suffering. Those vital organ capillary bed also suffering. Stem 1 says increase precapillary sphincter tone. Answer is correct. Stem 2, reduce urine output. I previously told, initially somehow they maintain the vital organ supply. Brain, heart and kidney. How much of blood going to perfuse kidney per minute? Yes, please. 20% of your cardiac output going to perfuse your kidney. If you have 5 liters per minute cardiac output, 20% means 5 liter into 20%, 1 liter. Per minute, 1 liter of blood going to perfuse your both kidneys. So what happened when it is become 4 liters? Somehow they try to maintain the renal perfusion, but still this 1 liter may be reduced into 800 ml. Your renal blood flow start to drop. Renal blood flow start to drop. Here your afferent artery, blood come into the glomerulus. Afferent glomerular artery. This one efferent glomerular artery. What happened now? Reduced renal blood flow, reduced renal blood flow, reduced renal plasma flow, therefore reduce GFR. So GFR means glomerular filtration rate, and reduce urine output. Second answer also correct. You have less renal perfusion, less renal plasma flow, therefore less glomerular filtration rate, therefore less urine output. Third one, reduced baroreceptor activity. Your baroreceptors are the one measuring the pressure in your vascular system. They are the one responsible for maintain optimal pressure in your vascular system. Your baroreceptors situated at aortic arch and carotid sinus. This is your aortic arch, this is your carotid sinus. What they does is they continuously measure your pressures. Continuously measure your body pressure. If you are having high pressure, what happens? These nerve cells start to stimulate. Those are mechanoreceptors. When it is stretched, sodium channel open. When it is stretched, due to high blood pressure, when it is stretched, sodium channel open. Then nerve impulse travel via aortic arch, nerve impulse travel via vagus nerve. Very good. Very good for me. Vagus nerve. Carotid sinus impulse carried via glossopharyngeal nerve. Glossopharyngeal nerve or 9th nerve, vagus nerve or 10th nerve. Carried impulse into the nucleus of tractus solitarius. If you have high blood pressure, more and more stimulation. Why? They stretch more and more. If you have low blood pressure, that stretch is reduced now. So baroreceptor activity going to reduce. If you have reduced baroreceptor activity, your nucleus of tractus solitarius in the brain will be panic. Why? This guy's baroreceptor activity reduced. Maybe due to low blood pressure. Then they are going to activate vasomotor center and cardiac accelerating center. Increase the heart rate and peripheral vasoconstriction. Both will be done simultaneously. So what happened now? Hypovolemia, less blood here, less stretch, less receptor activity. So stimulation of nucleus of tractus solitarius. So once they stimulate, they reduce impulse to the vasomotor center and cardiac accelerating center. So reduce baroreceptor activity, correct. Why? Less stretch simply. Next one, stimulation of juxtaglomerular apparatus. Now you have reduced blood pressure and blood flow, mainly to the kidney. What happened then? Your afferent arteriolar stretch, afferent glomerular arteriolar stretching reduced. Then they send impulse to the juxtaglomerular apparatus. This one called juxtaglomerular apparatus. This is your afferent glomerular arteries. This is glomerular capillaries. This one efferent glomerular artery. This one Bowman capsule, proximal convoluted tubule, loop of Henle, thin ascending limb of loop of Henle, thick ascending loop of Henle, and collecting duct, distal convoluted tubule and collecting duct. The cells from distal convoluted tubule and the cells from afferent glomerular arteries combine together and going to produce juxtaglomerular apparatus. This one is called juxtaglomerular apparatus. Combination of afferent glomerular artery cells and distal convoluted tubular cells. What they does is, if you have reduced blood pressure and blood flow in the afferent glomerular arteries, they are going to stimulate this part, going to secrete renin. If you have low pressure here, definitely glomerular filtration will be reduced. Glomerular filtration will be reduced. Less amount going to filter into your Bowman capsule. So what happened? Tubular flow will be very slow. Why? Little amount fluid is there. When tubular flow is very slow, what happened? They can reabsorb more and more sodium. When you have sluggish flow, you can drag anything that from that flow. If that flow is rapid, you can't take substance from that flow. The same thing happened here. Now flow is very sluggish, you can easily drag sodium. So they are going to take sodium, more and more sodium. Therefore less sodium delivering to the distal convoluted tubule. Less sodium to the distal convoluted tubule. Then this part cell going to activate. This part activate because of low pressure. This part activate because of low sodium. Both going to secrete renin. What renin does? Your circulatory angiotensinogen, which is produced from your liver, once they exposed to renin, they convert into angiotensin 1. Once they go through lungs, by helping angiotensin converting enzyme, they convert it to angiotensin 2. Stimulation of juxtaglomeralar apparatus, yes, low volume and low pressure and low sodium stimulate juxtaglomerate apparatus. Then it is going to secrete renin. What renin does is angiotensin convert into angiotensin 1, subsequently angiotensin 2. So it says increase angiotensin 2 in your body. It is also correct. All the answers are correct. Next one, what angiotensin 2 does? It going to constrict your vessels. It going to stimulate your thirst. It going to stimulate your sympathetic nervous system. It going to increase your aldosterone secretion. Aldosterone. What aldosterone does is go and act on distal convoluted tubular cells and increase the epithelial sodium channel. It going to take sodium and water reabsorption again back into your body. Somehow you try to survive from hypovolemia. Thank you very much.